Next, we come to a very important object class. I've probably said that about all object classes, haven't I? Well, this one does have special importance: data frames. A data frame is analogous to a spreadsheet. We've talked about a matrix being analogous to a spreadsheet, except that every element, every cell, had to have the same type of data. And that's not true with a data frame. A data frame has two dimensions, which makes sense if we are talking about this as analogous to a spreadsheet. And a data frame is a special kind of list. So a data frame actually is a list, but of a particular type, in which all of the vectors in the list are equal length. Think about research data in which you have individuals in rows, that is the unit of analysis in each row, and variables in each column. Well, all of the columns are of equal length because you're collecting data from every single individual, so that there are as many rows in column 1 as there are in column 2, and so on. But because a data frame is a special list, even though each of the vectors must within a vector have the same type of data, that's a requirement of vectors, they have to be atomic, different vectors can have different types of data from one another. And so each column in our spreadsheet could have different data than other columns in the spreadsheet. So think about when we store research data in a spreadsheet. Each of the columns represents a variable, and the variables can be of different types, that is, have different types of data. So that spreadsheet on which we collect our research data is just like an R data frame. That is why data frames have special importance when we're doing statistical analysis in R. It is typically the way that we will enter our data. In fact, many of the functions that import data into R assume that we're going to be importing data into a data frame. So read.table, read.csv, and other functions will automatically import into a data frame because that matches the most common way that data are stored in the spreadsheet that we're reading into R. Now let's look at how we work with data frames in R, including creating data frames and some of the common functions to work with data frames. We'll finish by importing data and see how when we import data using common R functions, it imports it as a data frame. I'm going to create a data frame called student data. Notice that I have 3 vectors that I'm creating. You see the 3 different concatenate functions here. Each vector is the same length. There are 4 elements in each vector. Each vector has the same type of data within a vector. That's required, otherwise it couldn't be a vector. But across the vectors, we have 2 different types. The first vector here is character. The next 2 are doubles. So let's create that using the data.frame function that will create a data frame. Now I'm going to provide names for the columns in the data. When I provide the names, the first column will be name, the second one ID, and the third one score. And let's take a look now at our data. Here it is. When we created those names, it automatically assumed that we wanted those for the columns. Remember that data frames are for storing research data, and the most common type of name that you're going to give are for variables. So that's what's created here. But notice also these numbers here, they have been added to the data frame as names for each of the rows. 1, 2, 3, 4. One of the requirements of a data frame is that you do have names for both rows and columns. So we can't completely suppress our variable names or our row names. Let's check to see what kind of data we have by looking at the class of the data. It is indeed a data frame. Let's see what type of data we have. It's a list. Remember that when you have list, there's no way of being able to list out all the types of data you have unless you access individually the members of the list. So if I were to indicate student data, and because data frames are lists, I can use that $sign. If I were to access one of those and ask for the type of data, let's say for name, then I can see that it's a character. But when I ask for the data frame as a whole, it just tells me that it's a list. What about the attributes of student data? The same sort of thing we get from a list, because a data frame is a type of list. We have the names of the variables, name, ID, score. We have the class being a data frame, but we also have the row names, which we did not add, but that are added automatically because data frames have to have names for rows and for columns. When we created the data frame, we could have included the names of the variables at the time of creation rather than afterwards. That's what I'm doing here in this code. Notice that I'm naming name, ID, and score while creating the data. And if I now look at student data, there it is. The names functions can include the names for student data. If I'm not going to assign names, then what it's going to do is just provide me what the names are. But I could also get it separately for rows, like I'm doing here, or for columns, as I've done on this line, with col names. Let me try to get rid of those row names. Now let's see what we have. They're not gone. I couldn't get rid of them because of the requirement. We have both column names and row names. But if you want for some reason to print this out without the row names, we can use the print command and suppress the row names with row.names equals false. There they are. Now I mentioned that many of the import functions will assume that we want a data frame. So let's go ahead and import the Mount Juniper elementary data, which is in a CSV file that I already put in my data folder. So I'm using the here function. I'm stating the header is true because there are headers to each of the variables there. And then the comma is the separator. Let's look at the class of the data. It's a data frame. Reading.csv assumes that you're going to want your data in a data frame. If I look at the attributes of the data, what I find here is the names of the variables, then data.frame is the class, and then the row names. Here's the Juniper data. There are 200 observations of 6 variables. This is what I just read in. You might have noticed that I clicked on these before to view the data. Look at how nicely RStudio will handle it when we click on a data frame. It opens this little spreadsheet, and it's using, to do that, the view command. So by clicking on Juniper data, I automatically use the view function. One thing to note, view, unlike so many of the functions, has a capital V. So if I close this and now type in view, instead of clicking on the data, which will do it automatically, there I get this data frame. And I can look at it very much like I would look in any kind of spreadsheet, because in essence, it is a spreadsheet. So we have our variables across the top, and we have our row numbers being used as the default names in the data frame across the side. We've been looking at objects, and the objects we've been focusing on are those that contain data. I don't want you to get the idea that all objects in R contain data. Functions, for instance, are objects. Remember, everything that exists in R is an object. So whether or not it contains data, it's still an object. But what we have focused on are the objects that do contain data. We call those data structures. So data structures are certain types of objects within R. Let's get a summary of the data structures that we have looked at. Data structures have dimension and are homogeneous or heterogeneous. If we look down here at this little list of data structures, we see that vectors, matrices, and arrays are homogeneous or atomic. They all contain the same type of data. Lists and data frames can have different types of data. The vector class is virtual because vectors are classified by data type. Remember that whenever we asked for a class of, say, a matrix, a list, or a data frame, we got back matrix, list, data frame. But when we asked for the class of vector, we got back the kind of vector that it was, whether it was character, or numeric, or integer. So vectors are classified by the type of data that they contain. Data structures have attributes and contain types of data. Data structures are objects. Everything in R, including functions, are objects. This little table here shows us that we can classify our data structures on the basis of whether they're homogeneous or heterogeneous, and on the basis of how many dimensions they have. A vector has one dimension, as does a list. However, that's because lists could have vectors of different length. But if we take the special case where we make the vectors all the same length within a list, then we can classify it like a spreadsheet in 2 dimensions, and that's why data frames have 2 dimensions. The only data structure in R that has more than 2 dimensions is an array. We're going to look at data structures in much more depth in a later learning cycle, but we have what we need to be able to get started playing around with these data structures, starting to write some initial scripts, and then when we learn more about them, we're going to feel even more powerful in how we can manipulate our data to prepare it for statistical analysis.